Yeah? Did anybody get it? I think you did. Now, was it long or was it short? So we had a few people who were doing it. So, and this is one of the frustrations that I actually, when I do some of these questions, I might do a long process and then I might see it another day, look at something different. It's like, oh, why didn't I just do this? So don't get frustrated, Michelle. But we said before that we've got isosceles triangles happening around the place. We said that we knew that that was 90 degrees. However, my big thing here, Sam, we're watching, is I love a good exterior angle of a triangle. Really love exterior angle of a triangle. So I want you to think about that for this one. And I want you to think, those two are dot. Would you agree that this one and this one are equal to each other? Why? Because we've got radius, we've got an isosceles triangle. Now, if we're looking at our exterior angle of a triangle, we're saying, if we're looking at this bit here, do you or do you not agree with me that this angle, these two angles, have to add up to be, oh, I'm still on, those two angles. Agreed? So that would mean that 2 ticks, oh, 2 ticks would have to equal 2 dots. And therefore the 2's cancel, therefore tick equals dot. Now we could write that up easily to say this angle, so angle OAC, so we could say angle BOC equals, I'm writing 2 dot, but I really want to put alpha, but anyway, yeah? And angle OAC equals angle ACO. Why? Isos. Agreed? Okay, and then I'd be saying, well, angle OAC plus angle ACO has to equal angle BOC, Y exterior angle of a triangle. So we've now got angle OAC plus angle, and BOX, where am I going? BOX equals OAC. So you know. Yeah, you can finish that one. I'm out. Hello out there. You might think it's going really fast. I am, because I'm wanting to give them a little bit of time to do their investigation, and I'm wanting to get at least up to question 6. Ooh, might only get to 4. Okay, we're looking here. Who got this one? No one continued in class. That's okay. All right, so draw the diagram. AB diameter. So when we see that, couple of things that we can do. Again, we're looking. Yes, we can see isosceles triangles there, but then we can also see isosceles triangles there. 2 isos. We agree with that. We read on. Center of a circle, okay? X is a point on the circle. AX is produced. Again, when you're reading this, you are going to have a question soon that will not give you that diagram, and it will say AX is produced. What does that mean? It just means keep going. Okay, it is produced to a point Y, and we've got OX equals XY. So they've put that in for us already. Tick, covered on the diagram. Prove that angle YOB, so this angle here, YOB is 3 times the size of angle XOY. So XOY, and this is where, seriously, just do something. So I'm going to start with XOY. And we're going to start by saying that's not very good. We're going to start by saying let angle XOY equal alpha. Agreed? Let's hit it. We're going to put an alpha there. What do you feel compelled to then put? What else could be alpha? The other on the, thank you, Keats and Ollie, that's right, because we've got an isosceles triangle, and you go, I don't know if that's going to help us at all, because we're going out. Dave. Love that exterior angle of a triangle, man. So once again, if you're looking, you can see here's a triangle, and can you see how this is extended? Right? It's almost like I want to rename it of extended. But it is the outside, that's why it's exterior. So, what can you then tell me this angle is here? Yes! 2 alpha. Oh, I heard you, Rian. Where'd you go? Right, it's isosceles because we had put that there. So if that's 2 alpha, well, that's 2 alpha. Now we keep in mind, what are we trying to get to, Joe? We're trying to get to this thing. Ollie, can I come to you with the mic or not? Or do you want to come to me? Okay, I'll just repeat what you say, sure. Isn't it the exterior angle with the 2 alphas again? Yes, it is. I'll choose a different colour now. Yes, so here's my triangle here. Yes? And we're extending it out there. So that whole angle there, I have to get rid of that now because then you can't see it, but that whole angle would have to be 4 alpha minus that 1 alpha that we have, and so therefore that's 3 alpha. Nice. Okay, so we're letting X, O, Y be alpha, and sometimes it's really hard because you're getting so caught up in it and you're just putting stuff in there. Oh, what one did I do first? So, you know, try and remember, write yourself a little bit of a note or try and write a little bit up as you go. So this was alpha, that meant X, Y, O was alpha. So we're going to say that equals angle X, Y, O. Why was that? Isosceles. Then what did we do? We said this, and we then went to that. So we can say A, X, O. Now remember, be careful for the person reading it. So X, no, that's not what I just said. Too many letters. A, X, O. So A, X, O. We're going to get to the 2 alpha. I'm actually going to say the angles first. I'm going to say it equals this angle plus this angle. So angle, it equals angle XYO plus angle XOY. Exterior. Oi, it's Friday. Exterior angles of a triangle. And so that equals alpha plus alpha, which equals 2 alpha. Off. This was 2 alpha. What did you do next? We said this one was 2 alpha. Correct. So we can say angle AXO equals angle XAO. We said AXO equals XAO. Yep. XAO. Yep. Because it was isos. Which equals 2 alpha. Okay, so now we're saying XOB equals AXO plus angle XAO, Y, exterior angle of a triangle, which is, oh, I should be good. I get a bit excited sometimes and I go too fast. We know, they say. Yeah? So we've got that it's 4 alpha. And then I think you can finish off and do the, well, hang on, 1's an alpha, therefore ends up being 3 alpha, and therefore it is 3 times. And one of the things I forgot to say at the beginning, when we said let x o y equal alpha, you could even say to show. Right, what does this mean? YOB is 3 times, so we want to show YOB is 3 times that, so 3 alpha is what you're aiming for, and then when you get there, you know you're done. So we've got AB as diameter of a circle, centre O. So we draw our circle. Not bad. Okay, so centre O, I normally will wreck it with my AB, but anyway. Centre, is that in the centre? Close enough. A, B. So, if we didn't know before, CD is a chord parallel. What is a chord? That's right, from one side to the other. Diameter is technically a chord, but it's a unique special. So we're going to go CD. So I tried to do it a little bit differently up here. So we're going to go C to D. And what's the next thing we must do? Draw the parallel lines. I'll wait for you. Okay, we want to prove that BC bisects angle DCO. Oh, geez. All right, read that again. BC. So let's connect B and C. Oh, it's almost like we have alternate angles. Oof. Anyway, prove that BC bisects the angle DC. This is your O, right? Ooh. Regardless of whether. So what does it mean to bisect? Cuts equally. So we need to let one of these be alpha. Agreed? I feel green coming on. So shall we do this one? So let that one be alpha, and then what's going to happen? I'll give you a moment to think. Hey, if some of you have not actually drawn on your diagrams yet because you think, oh, I don't know, I don't want to get it wrong, shame on you. You must put something down. So we've got parallel lines, so we want to make sure that we use that. We also had centre of a circle, so we've also got, as Michelle said, radius. She said radii, she was sounding impressive. Now, I would be saying, if you're not sure what to do, how could we use our parallel lines? Do we agree that this has to be alpha? And then? Doesn't that have to be alpha? Why? Bang, we're done. We have now proved that they bisect because they equal each other. So remember we said if that was dot, that had to be dot and so on? We're done. Now, someone just said it makes sense when it's on the board. And that's another tip, is that if you can't see something, sometimes draw your diagram a little bit bigger. When it's small, it's very hard to see certain things, so go big. I used to do these when we had the white tables. We used to get the texters and we draw them on the table. And just, it's great. Now we can't afford even to have the texters. What I would ask you to do next lesson, because I know for homework is your investigation, right? For next lesson, I would like you to cover up the example here and just look at the words and see if you can do it without. That one is slightly harder, especially with the perpendicular and what have you. So have a look. It's one way. That's one way how they have explained. You can always do it another way. And if you're ever in doubt, let your neighbour read it. We will get to the point where I'll have some work solutions for these that I can show. You can compare, but the odds that your explanation is exactly the same as someone else's, you have to sort of weigh up. Is what I have said okay? Does it make sense? Anyway, on to number 5. See, I said we could do up to 6 this lesson. We're on track. Although, have I just cursed you with this question? Okay, so hit your circle. Oh, had sound from the class and put me off, but you know, no, we're not really. My finger slipped. Oh, a little bit eggish. A little bit eggish. I want to go again. Okay, I will. I shouldn't, but I will, because you guys are still drawing yours. Oh, not too bad, a bit wonky here. Anyway, so A, B, and C are 3 points on a circle. Now, when you draw this, can you draw it so, no, and Jay's got it too. Can you draw it so your 3 points do not make, thanks mate, do not make an equilateral triangle, because then you might assume things that you're not meant to. So as tempting as I just sort of put it maybe here. And shall we start here, A, B, C? A, B, C. A, B, C. Let's see if you can draw what they've asked you to. So some of us with a little bit of noise, the bisector of angle CAB. It's like, well, I don't know what that means, but how about we actually get angle CAB? So I'm going to connect C to A. Oh dear. Try and use a straight line, unlike my good self. And yes? So now we're saying we want the bisector of this angle. So are you agreeing? We've got a line that just goes all the way through. So right smack bang in the middle. So you might not be able to see the whole thing until you draw one little bit. So once you've drawn the CAB, then you might get the next bit. As I have done that, it says it's the bisector, so I'm going to straight away put this information in. So I'm going to put alpha, alpha, because it's told me. Okay, it cuts BC at P. Oh, well, I haven't got BC. Let's draw it in. B. C, it cuts there at P, and the circle at. So does it now make sense? Where some of you were reading that and going, what? What? Where's P? Where's Q? As you draw in those bits and pieces, it will make sense. All right, to prove that APC equals ABQ. Oh, ABQ, I didn't do that nicely, did I? Okay, so prove APC equals AB, oh, I better draw in BQ. So we're trying to sort of get an expression for that angle there. I don't like to do that really, because then you might assume that it's the same angle, but I want to keep an eye on the fact that this is the angle I'm trying to get to. Correct? Okay, so what is it that we can do? And I will give you one hint. There is a theorem. There is a theorem, and in my day it was a groovy little band. There were two little boys, crisscross, and they'd go crisscross. Will make you jump, jump, wiggida, 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 whack. Ollie started with, okay, we've got this angle here and we wanted to prove that that one equals this one. Now, normally we don't like to introduce a second variable. But in this case, we knew these were bisecting, so we had to put that in. So I'm going to go, let's make this, call it another one. If this one's alpha, what should we call this one? Beta. Therefore, that one's beta. But remember, we're trying to get to this. Now, using this crisscross, angles subtended by the same arc, right? If this is alpha, that's alpha. Does that help at all? It's not. And another tip, this is why we learn these things. We've got that big. We've also got a bigger triangle here, do we not? And then we've got a little one here. I would give you more time to think and play, but I'm now over my time limit. I could have a look at this and say this would be 180, take alpha, take beta. Would you agree? Looking at this triangle here. And then, if I'm looking at that bigger one there, I could get this angle, couldn't I? Add the alpha, and I reckon it will end up being beta. But that's a bit messy. I can do it a different way, but we're running out of time. So it can be done. If you haven't got to it, you might just want to listen a little bit. So we have our, this was the original, correct? Original. But you then get your own point. So let's imagine it was here. Yes? And you had to find, it was, what was it? Read the thing. It was for when t was 4. So when t is, when t is 4, your A ship was 2.6, I think it was. So 2.6, yeah, see, I've done this before. Whereabouts? I've forgotten whereabouts it was though. Here? So let's say it was here. Okay? So you would be working out, this vector hither, correct? You've got your point here. You should have this point here, right? Well, you do have it, it's 2.6. And you want to be travelling this distance in 4 hours. So that should be able to go, yeah, I can find my velocity vector. So you would then have, I don't know what v you're up to, and plus t, correct? Check it, that it works. Then what is happening is you have got a wind. You're listening to this, Joe? Because it doesn't look like you're listening. And if you then ask me, I'm going to go, no, mate, sorry. You've then got a wind that they say is blowing perpendicular to this. And what did I say it was? Upwards, downwards? Upwards. Okay, so the wind is coming. I'll just draw that. Yes, I'll draw it. So the wind is coming whoosh, 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 whoosh. Now, let's imagine that this vector you ended up finding was, and you know what? We're even going to call it A, B. What would your wind vector then be? Negative B, A. Flip, reverse sign. Correct? Whoosh. It's going to push you off, and we said you can give it a reasonable. So you can say, research, wind is blah, 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 or you might just want to say it's a low, but it will push you slightly off course. Do you agree? If it's coming this way, it's going to push you off course. Now you're going to go off, course for how long? For 2 hours. But again, you've got your starting point, you've got your new velocity vector, so this will now be something, something, replace t with 2. You would find out where you stop. Does that make sense? So let's imagine, I hope it's not on here, let's imagine it's out here, or where it could be there, doesn't matter, right? But you now have to, from the original course, when t was 7 hours, it was here. So you have to now go to here within how long? 5 hours. Okay, what are your 3 vectors? You've got 1, 2, and from the origi-dig, you would have had that all the way through because it's vector addition. Show some diagrams, but that's what we should. So it's actually not that difficult. But where do I want? I want the explanations. I want you to explain some of the things about what can push you off course, all that sort of jazz. And remember, it's to the captain. So look, don't panic. You're nearly there. Okay? We're keeping in mind this is not going to be perfection of something that you have spent 8 weeks on, nor did I want you to spend 8 weeks on this. Love you.